Okay, Longhorns, this is the review for 3.2 quadratics test for Algebra 2 Pre-AP. And we're going to start by solving by graphing. And for these, you're just going to use your graphing calculator. First thing you need to do is make sure you set your equations equal to 0 before you graph. So what I'm going to do to set this equal to 0 is I'm going to move, or I'm going to subtract a negative x squared, and I'm going to add a 54. And when I do that, that gives me a 0 on this side of the equation. And on this side of the equation, I'm going to have a minus x squared here and a plus 54. So when I rewrite this equation, it's going to be 2x squared minus 12x plus 54 equals 0. And now I'm ready to graph that. I can put that in my graphing calculator under the graphing tab and set that f of x equals 2x squared minus 12x plus 54. And what I'm going to find is that I have a parabola that's kind of floating above the x-axis. So in this case, I have no real solutions. I have two imaginary solutions, but I'm not going to be able to find those by graphing. I would have to use the quadratic formula. So we're just going to leave it at that. Let's go to the next one. The next problem has solutions. All right, so for problem 2, again, we have to set this equation equal to 0, and it appears that it is already set equal to 0, but it's really not. So what you need to understand is that this y right here needs to be on this y right here needs to be on one side of the equal sign, and everything else needs to be on the other side. So since the y is positive right here, I'm just going to move everything else over. And the way I do that is I'm just going to add each one of these terms to both sides of the equation. So what I end up with is y equals 2x squared plus 18x minus plus 40. Okay, and then I'm going to put that in my graphing calculator, and what I end up with is a graph that looks something like this. All right, it's not perfect, but basically what I ended up with was a parabola that crosses the x-axis at x equals negative 4 and x equals negative 5. So if I was looking for the solutions, that's what they would be. They would be wherever the parabola crosses the x-axis. So that happens at x equals negative 4 and x equals negative 5. All right, I'm going to skip over to problem number 5. We're going to solve using the quadratic formula. And here you see that I've written the quadratic formula is written here for you. You need to memorize the quadratic formula. We're not going to give you the quadratic formula on the test. You have to have it memorized. So you can remember it by the little chanty song, or just memorize it. So just practice, practice, practice. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So just remember that's x equals. So you're not going to be putting any x values into this formula. These are all numbers. These are all the coefficients that are in front of your x squared, your x, and your constant. Okay, so the first thing we're going to do is identify our a, b, and c. Then we're going to plug them into the formula and solve. All right, so here you can see I have plugged in the coefficients. A is 3, b is negative 2, and c is 12 into my quadratic formula. And right here I have a negative b plus or minus the square root b squared in parentheses minus 4 times 3 times 12 all over 2 times a, which is 3. Now I'm going to simplify this, and what I would recommend is don't try to put all of this into the calculator at once. Take care of your discriminant first. This part right in here, this negative b squared minus 4ac, this right here is your discriminant. Some of you still do not understand or do not know what part of the quadratic formula the discriminant is. It's the one that's inside the square root. It's the one that gives us specific information, which I will review with you later. I'm going to go ahead and simplify this and see what we get. All right, so as you can see right here, I have taken care of the discriminant. I have found that my discriminant, which is going to be 4 minus this right here, ends up being a negative 140. Well, what I need to do now is I need to simplify this radical. I know that I'm going to have 2 imaginary solutions. So because of the negative sign inside this radical, I'm going to need to take that out, and I'm going to have to use my imaginary number I in my solution. So what I need to do here is I need to take this 140 and I need to find out what all the prime factors are. Well, the prime factors of 140, after I put it in my calculator, I get 2 squared times 5 times 7. These are all my prime factors. So what I'm trying to find is, well, is there anything in here that I can take the square root? Yes, I can take the square root of 2 squared. So the square root of 2 squared is just 2. So I can pull that out of my radical. Plus I can pull this negative sign out and make that an I. So when I rewrite that, it looks like this. Okay, so I get 2 plus or minus 2i root 35, because that's what I have left, over 6. Now you might think you're finished here, but you're not, because this right here can still be reduced. So if there's some number that will divide into each one of these parts, then I will be able to reduce it some more. So it's not completely reduced yet. If you forget that step on the test, you might lose a couple points, but at least you'll get most of the points correct for the question. But it's best if you go ahead and reduce these. That way you get all your points. So I can divide each one of these by 2. So this is what that's going to look like. And so now I'm finished. I have 1 plus or minus I, which is 2 divided by 2 is just 1. And we don't really need to write the 1 here. If you did, I wouldn't count that off. But anyway, I root 35 over 3. So this is your final answer for solving this using the quadratic formula. So we actually do have 2 solutions here. One of the solutions is 1 plus I root 35 over 3, and the other one is 1 minus I root 35 over 3. So if you were wondering, well, Ms. Stiles, that's not 2 solutions, that's only 1. Well, it is 2, but if you break this apart into its 2 equations. We actually have 2 equations displayed as 1 here. Okay, we're going to go on to the next kind of problem. All right, so let's move on to number 7. We're going to solve each system algebraically. Now this is a system of a line and a parabola. So what we're going to do is we're going to solve this system algebraically, and then we're going to write down our 2 points where the line crosses the parabola. You can also check your work by graphing this in the graphing calculator. If you can, graph it in the graphing calculator. This one, number 7, though, if you tried to graph this in the graphing calculator, you'd have difficulty unless you solved everything for y. And since our quadratic is written as y squared, the only way you could really graph that in the calculator is if you changed your x's to y's and your y's to x's. So we're not going to do that. We're just going to solve this with the variables that it has. And in reality, if we were to graph this, it would actually be a sideways parabola. So that's not something that your graphing calculator is capable of doing as a function. So we're going to just, we're going to solve this by hand. So the first thing I'm going to do is I'm going to go ahead and rewrite this equation right here so that it is x equals. Since this one is x equals y minus 5, I also want to make this one an x equals something. So what I'm going to do is I'm going to move this 2y, I'm going to subtract 2y from both sides of the equal sign, and I'm going to rewrite this second equation as x equals y squared minus 2y minus 3. And then what I'm going to do is I'm going to set those two equations equal to each other, since x equals y minus 5 and x equals y squared minus 2y minus 3. I can set those two equations equal to each other and then just solve for y. All right, so far what I have done is I have moved the x and the 2y to the other side of the equal sign, and I rewrote it as, I moved the 2y over to the other side of the equal sign, and I rewrote it as x equals y squared minus 2y minus 3. Then I set the two equations equal to each other. So I wrote y minus 5 equals this right here, since they equal each other. So I set them equal to each other, and then I finished setting this equal to 0. So I subtracted a y here and I added a 5. I subtracted a y here and added a 5. So I'm setting this equal to 0. So that makes this side equal to 0. And this side is equal to y squared minus 3y plus 2. Now I can factor this. So I'm going to factor this, and then that's going to give me my two values for y. All right, so here you can see I found the two values that will multiply to give me multiply to give me a positive 2, but add to give me a negative 3. So those values are negative 1 and negative 2. And so I factored this out, y minus 1 times y. All right, so in this problem, problem number 9, you have to write the equation in vertex form for the given graph. And in addition to that, I'm also going to have you write it in standard form. So the one thing that you need to make sure you understand for the test is the difference between these two forms. Okay, vertex form is the form y equals a times x minus h, the quantity squared, plus k. That's vertex form because it gives us the vertex hk. Standard form is y equals ax squared plus bx plus c. And the information that this particular form gives us is c, which is the y-intercept. And also the standard form is the form we use when we're using the quadratic formula. So you need to understand the difference between these two forms. Now the vertex form, this form right here, is also the form that we write when we're completing the square. So whenever you're doing a completing the square problem, this part right here is what you're trying to create. So that might help you keep all of these different formats and forms and formulas and things separated if you understand what they are and where they come from. All right, so we're going to be writing this equation in vertex form first, and then we're going to write it in standard form. So I'm going to go ahead and erase this so we can do that. So if you need to go back and rewatch that again or write it down somewhere, that's fine. Okay, I need space to work. So the first thing I'm going to do when I'm writing this in vertex form is I'm going to look for the vertex, and that's right here. And I'm going to write it down. So my vertex is at 3, -3. So I've got most of my vertex form already done just by having the vertex point. So I'm going to go ahead and write it down. Y equals A times X minus H. Well, H is 3, so minus 3, the quantity squared, minus 3. Because plus K is just, you just keep the same sign. So since that's a -3, I'm going to write a -3 right there. Now what I need to find is I need to find A. And I'm going to find A algebraically. I could try by counting how many units down I go and so forth. And you could probably use this little trick sometimes, but sometimes you can't. And so if you can't really tell where the next point is, then it's always a good idea to go ahead and solve it algebraically. Now I'm going to use this point right here to solve it algebraically to show you that our A value is going to be -2. So let me show you how that works. I'm going to take this point. Now this is point 4, -5. And I'm going to take that point 4, -5. And I'm going to use that point to help me find the value for A. So what I'm going to do is I'm going to take this -5 and I'll plug it in for Y. And then I have my A. I don't know what that is yet. And then I'm going to plug in my my 4 in for X. So 4 minus 3, the quantity squared, minus 3. Now I just simplify that and find out what A is. Okay, so I have a -5 equals, now 4 minus 3, that's 1. 1 squared is 1. So I have 1A minus 3. Now I'm going to add 3 to both sides. And when I do, voila. What pops out? My -2. So my A is -2. Now all I have to do is write my entire equation, including my A, and that's my answer. So I have Y equals -2 X minus 3 squared minus 3. Okay, so this is where I'm getting this information. I'm taking this equation that I got up here at the beginning, and I'm just rewriting it down here, except this time I know what A is. I know that A is -2. So now that I have the vertex form, I can write the standard form from here. And this is what you're going to have to do later on this review and on the test. So we're going to go ahead and do it here anyway, just to give you a little more practice. So I'm going to show you what to do here. The first thing we're going to do is we're going to take our equation, and I'm going to break this binomial squared apart into its two binomials. So x minus 3 squared is just x minus 3 times x minus 3. And then I have this minus 3 down here. I'm going to go ahead and FOIL this part right here. I'm going to FOIL that. So I have -2 x squared. And -3 plus a -3 is -6x. And a -3 times a -3 is +9. So there's that perfect square. So you should probably recognize that from when you were doing completing the square. So if you didn't recognize that, then this is kind of like completing the square in reverse. All right, so we're uncompleting the square. Anyway, we're going to go ahead and distribute the -2 now. I'm going to move this up a little bit. Let me move it up. Running out of space. Okay. Let me write it over here. Okay, so I'm gonna just, I'm gonna move this up here just to kind of get some more space here. Okay, so negative 2x squared plus 12x minus 18 minus 3. Oops. Let me stop this for a minute. All right, so instead of trying to go to the right with this, I'm going to go to the left since I have a little more room over here. What I'm doing is I'm distributing this negative 2. And the very last thing I'm going to do is combine the last two numbers together. So I'm going to go ahead and do that. Okay, so I get a negative 2x squared. Negative 2x squared plus 12x minus 18 minus 3. And then I just combine this last set together. Negative 18 minus 3 is negative 21. And that's it. Now we're in standard form. Okay, so big question of the day. How do you know that your vertex form, which is this form right here, and your standard form, this one right here, how do you know that those are the same parabola? Well, the one way you can check that is to graph them on the calculator at the same time. So you graph one, hit tab, graph the other one, and if it graphs together, then it's the same parabola and you've done it correctly. If it doesn't graph together, if you get two separate parabolas, then you've made a mistake somewhere and you need to go back and check your calculations. Okay, so that's one good way to check to make sure that you got it right. All right, for the next kind of problem, we're going to write the equation in vertex form again, using the given information. This time we're just going to do the vertex form. And it's basically the same thing we just did, except they give us the vertex and a point. So I'm just going to work this out. I'll walk you through it, and then we'll move on to the next thing. All right. So the first thing I did was I took the vertex, which was 6, 7, and I plugged it into my vertex form. Y equals a times x minus 6 squared plus 7. Now remember, if this was a negative, then this would be a positive. So it's minus whatever this number is. So this is minus 6. And then the next thing I did was, well, I still need to find a. I don't know what that is. So I'm going to use this other point to find a. Well, I plug 19 in for y. I plug 4 in for x. And I simplify. So 4 minus 6 is negative 2. Negative 2 squared is 4. So I have 19 equals 4a plus 7. And then the next step is to just solve for a. So subtract 7, I get 12 equals 4a. Divide by 4, I get a equals 3. So now that I know a is 3, I can come back up here and I can rewrite this equation that I have. Y equals 3 times x minus 6 squared plus 7. And then rewrote it down here. And that's it. Put a box around it and you're done. All right, the next problem we're going to do is one like number 14. Here we're given 3 points, and we're to write the equation in standard form with the 3 points. So this is the same kind of problem we did last 6 weeks, where you had to write a system of 3 equations. So we're going to make an equation out of each one of these points, and then we're going to solve it using our graphing calculator, our TI Inspire, and we're going to plug it in under systems and solve it as a system. So this is what the equations are going to look like. All right, so what we have done here is I have taken each one of these points and I've created an equation that I'm going to put into the calculator as a system and try to solve for A, B, and C, okay, or X, Y, and Z in this case. We just switched A, B, and C to X, Y, and Z so that the calculator can do the system. All right, so what we're doing here is we're taking this X value, this negative 11a, and we're plugging it in for x squared. So if I square this value right here, I'm going to get 121. So my first term is going to be 121x. Then I take this, and it's going to be my middle term, because remember we're writing this equation right here in standard form. Oops, it's not writing clearly. Ax squared minus bx plus c. So this is what we're trying to get. And so what I'm doing is I'm taking each one of these x values, I'm plugging it into this x and this x to get these values that are in front of my variables for my system. So that's where those are coming from. So if you're like, well, where are you getting those numbers? Well, the first one is going to be, this first number right here is going to be this number squared. So 121. And then I use that number again here, negative 11y plus z. And all these are going to just be plus z on the end. Okay, so the next point here, I'm using this negative 6 for x and 18 for y. So I put my 18 in for y, and I square my negative 6. That gives me 36x. I keep it as a negative 6 here for the middle, and then just plus z. And then this last one, again, I'm squaring this negative 8 at 64. Then I subtracting the 8 plus z. Now I'm going to put this in the calculator, and I'm going to solve for systems, and what I get is, okay, so I get this value right here. I get 2, 36, and 162. And so now what I'm going to do is I'm going to use those values, the 2, the 36, and the 162, to plug in for A, B, and C in my quadratic formula. And my quadratic equation, I mean. Okay, so that should be a plus. Okay, so I'm going to plug them in, and here we go. We have 2x squared plus 36x plus 162. All right, so how do I know that's the right equation? Well, you can graph it. So how to check it? Graph, Control T. Graph, Control T. That'll take you to the table. And your table in your calculator should have these points. You should have a negative 11 and an 8, a negative 8 and a 2, and a negative 6 and an 18. If you have these points in your graphing calculator, when you do a Control T, then you know that you did it correctly and that you have the correct equation that has these points in it. Okay, and that's it. All right, for problem 16, we are solving this quadratic inequality, and then we're going to graph it on the number line. All right, so the first thing you want to do is you want to set your equation to one side of the inequality and put a 0 on the other side. And then we're going to just solve by factoring, and then we're going to graph the solution. All right, so what I'm doing here is I am subtracting a 6, adding a 2y squared, and subtracting a 13y from the left. And so whatever I do to the left, I have to do to the right. So I'm doing the same thing over here. And I'm just going to set this is setting this equal to 0. So that makes this 0, and we're going to rewrite this. All right, so when I rewrote my inequality on this side, I ended up with combining these. Negative y squared plus 2y squared gives me a y squared. And then, of course, the 6 is canceled out, so that's just 0. And then a 4y minus 13y is a negative 9y. So now I'm going to factor this. So the only thing these two have in common is a y, so I factored out the y. So I have y times y minus 9 is what's left. So these are my two factors, y and y minus 9. So I set those both equal to 0, and I get y equals 0 or y equals 9. Now, what I need to do is I need to check to see where I'm going to be shading. So since this is a greater than, not equal to, at 9 and at 0, I'm going to have open circles. And then I need to figure out, am I going to shade inside in between these, or am I going to shade outside these? Okay, so the first thing I'm going to do is I'm going to pick some number that's fairly easy for me to substitute into my equations, and I'm gonna try the number 1. So if I plug a number 1 in to my equations, and the equation is true, then I know I need to shade between the circles. If it's not true, then I'm going to check another number, maybe check a -1 or check 10. And I'm going to try those numbers. Now, if one of those numbers works, then I'm going to shade that direction. Okay, so let's go ahead and take the number 1. We're going to plug it in, and we say, well, 6 minus 1 squared is 1, so 6 minus 2 plus 13. Is that greater than 4 minus 1 plus 6? Okay, well, 6 minus 2 is 4, and 4 plus 13 is 17. And indeed, that is greater than 4 minus 1 is 3 plus 6 is 9. So that's true. So that means that I'm going to be shading my inequality in between the circles. And that's it. All right, for problem 17, we are going to find the discriminant. Okay, that's part of the quadratic formula. The part of the quadratic formula that is the discriminant is the b squared minus 4ac. This is the part that's normally found underneath the radical in our quadratic formula. So to find the discriminant, all we're going to use is that piece. And so that piece of the quadratic formula will tell us how many solutions we have and what kind. So if it's a negative number, it's 2 imaginary solutions. If it's 0, it's 1 real solution. And if it's a positive number, then it's 2 real solutions. So let's go ahead and find our A, B, and C. The first thing we need to do is set this equation equal to 0 first. So that means I'm going to have to add a 7 to both sides and rewrite my equation. Find my A, B, and C and plug that into my discriminant formula. Okay, so I have rewritten my equation. So I have as negative 6m squared minus 8m minus 3. My A is negative 6, my B is negative 8, and my C is negative 3. And I'm going to plug that into my discriminant formula. So negative 8 squared minus 4 times the negative 6 times the negative 3. Now notice that I put this negative 8 into parentheses, because a negative 8 squared is not negative 64. It's 64. So be careful with that. That's a common mistake, and it will get you the wrong answer. When I put this in the calculator, using my parentheses, I get negative 8. So my discriminant is negative 8 for this particular problem. Now, if I were to actually try to find the solutions for this quadratic, I would have 2 imaginary solutions. Okay, the next thing we're going to do is problem number 20. And this problem is similar to one of the problems you have on the test. So it's really important to make sure that you understand how to write this. Now, the equations for these word problems are going to be at the bottom of the last page of your test. So make sure that you look for those equations. For this one, we're going to be using the equation for feet. So this one says a world famous cliff diver, Arturo Rodriguez, is at the World Championships in Acapulco, Mexico. Arturo launches himself from 136 feet above sea level at an initial velocity of 12 feet per second. Determine how long it will take him to be at a height of 40 feet. Okay, so first of all, we need to write a couple of equations so that we can graph it in a calculator and then analyze the graph. So the first thing we're going to do is write our equations. So we know that it's in feet. So we know we're going to be using negative 16x squared. The next thing we're going to include is our velocity plus 12x and the initial height plus 136. Now that is going to be the quadratic part of our equation. The other part is going to be this height of 40 feet. So we want to know, when does he hit that height of 40 feet? Well, we need another equation for that. So that equation is going to be a line, and it's going to be y equals 40. It's going to be a horizontal line at 40. So when we graph this, we're going to get a parabola that's upside down like this. The initial launch height is going to be somewhere in here. So here's my x and y axis. We launched from 136 feet, but we want to know, and I'm going to change colors here, we want to know when he gets here. That's what we want to know. So when you're solving all of these word problems that concern motion, there's some things that I want you to realize about the graphs that you have. You're either going to have one single graph. It could be just a single parabola, and maybe you're just looking for the place where it hits the ground. Well, that's going to be on the x-axis. Or maybe you need to know the maximum height. That's going to be the vertex. Or maybe you need to know, maybe you'll have another line in the equation, and you need to know the intersection. That's going to be these points here. So it just depends on what the problem is asking for. Is it asking for an intersection? Is it asking for the maximum point, the vertex? Is it asking for when something hits the ground or when something hits the water? Okay, so depending on what they're asking for, sometimes they're asking for a time frame. So if they're asking for a time frame, you're actually measuring the differences in the x's. So if I wanted to know, well, how long is he above the ground, or how long does this happen? So you would need to take the difference of the x's to find out how long that is. Okay, so it just depends on what the question is asking you. This one about the cliff diver is asking for, when will he be 40 feet above the water? So that's this point right here, this intersection. Okay, so when I graphed that in my calculator and I got the intersection, it told me that it would hit the height of 40 feet at approximately 2.85 seconds. So 2.85 seconds is the answer to this question. All right, so go ahead and solve the rest of these word problems, and if you have any questions about any of them, or you can't find the answer, or you're not sure what to do or where to look, please ask. Ask in class, or come to tutorials before or after school and ask me. For problem 24, Mrs. Vaca wants to frame her oil painting that she has crafted. If the dimensions of the picture are 40 inches by 24 inches, and she adds a frame of uniform width on each side, creating a total area of 1,350 inches squared, find the dimensions of the frame. Well, the first thing you want to do is draw a picture. And so I'm going to draw a picture right here. And she's the size of the picture, the dimensions of the picture are 40 by 24. So I'm going to put the picture in here, and it's 40 by 24. So that's the size of the picture. We know that the frame is uniform width. That means that these sides are all X. Okay? So we know that the total area, all of this area is 1,350. So 1,350 inches squared. Okay, so since we know that's the total area, we can find the value of X by setting up a quadratic equation and setting that equal to 0. So let me go ahead and set that up. We're going to do 24 plus 2x because in order to get this length right here, I need to add the 2x to the 24. So this side is 24 plus 2x. This side is 40 plus 2x. And if I multiply these two things together, I should get this. So I'm going to go ahead and rewrite that so that, let me move it over a little bit, so that we can see what the quadratic equation is going to look like. And then we're going to put that in the calculator and solve. Okay, so what I found when I put this in my calculator, I put it in as I put it in the calculator exactly the way I wrote it. 40 plus 2x times 24 plus 2x equals minus 1350 equals 0. All right, so then I put that in the calculator and I get that x equals 2.8. Well, that tells me how what the width is of the frame, but the question is asking me what are the dimensions of the frame. So what I'm going to have to do now is I'm going to have to plug the 2.8 back into this part of my equation to get those dimensions. So I'm plugging the 2.8 back in. So I have 40 plus 2 times 2.8. And when I plug that back in, it gives me 45.6 by, and then I need to figure out what the other one is. So 24 plus 2 times 2.8. And that gave me 29.6. So it's 45.6 by 29.6. Those are the dimensions of my frame. So keep practicing. Make sure that you've done all of your word problems and you understand how to set these up. They're very similar. The only difference in some of them you're going to have to subtract the 2x. Some of them you add the 2x. It just depends on which values they give you. Did they give you the values for the rectangle on the inside, or did they give you the values for the rectangle on the outside? And are you having to add or subtract to get those x values? So that just takes practice. So my recommendation is to just do all of the word problems, make sure you understand how to do them, and be prepared, because on the test, you never know if you're going to, what kind of problem you're going to get. Just be careful, read the problem 3 times, make sure you understand what the problem is asking for, and draw pictures. And that's it. So good luck on your test. Make sure you come to tutorials for help. Come to tutorials before the test, not after. So make sure you're there and study, study, study. Be ready. All right, so after reviewing the video, there is an issue with my pointer, so please just disregard the pointer as you're watching the video. If you go back over and watch it again, I'll warn you about it in class as well. I don't know why that's happening. I need to call the company. It's a technical issue, so unfortunately, I like using the pointer so I can point to exactly what it is I'm talking about, but for some reason it's not working on my iPad, so I need to call the company and find out what's going on with that. But anyway, good luck on the test, and make sure you are practicing a lot.